In this lesson, we will talk about the extensive tolerance analysis capabilities of GraphiCAD 2010. The tolerance analysis capabilities can be used by a design engineer, by a quality engineer, as well as a manufacturing engineer at any stage of the design process. Essentially, you can allocate a tolerance to any freedom of any geometry, whether it's a part or an assembly, a constrained assembly, and then you can apply Monte Carlo tolerance analysis method to any of the measurements or calculated values. To show you the concept, let's say I'm just going to create a geometry here, and I want to give a tolerance to the diameter of this circle. So I just move my cursor over the freedom I want to allocate the tolerance, click the right mouse button, and I can allocate a tolerance. So you can enter a nominal value here if there's no nominal value in there, and you can enter a delta, let's say plus minus 0.75. I'm exaggerating a little bit so you will see what happens. As soon as this tolerance is given, the entity is randomly changed based on the tolerance that you have given. And if there was a measurement here, sorry, I'm going to measure the radius of this. That is changing in real time. I can also allocate, for example, a polar tolerance to any point. So the center of the thing is, let's say, going to fall within a circle whose radius is 0.50 millimeters. And now the geometry has been excised. Likewise, I can take for example, line. I can say the length of the line. Nominal value is 40 millimeters, but the high delta and low delta, because of tolerances, is a certain value. And I can measure the length of this line, for example. And you can see it's affecting the tolerance. I can, for example, measure the origin X of this. So this way, what you can do is anything in the value bar, you can click a right mouse button next to that value bar box and enter a tolerance. And once a tolerance has been allocated, I can select a measured or a calculated value and simply say tolerance analysis, select my sigma distribution that I want to satisfy. Every company has a standard. Let's say you're designing for 6 sigma, you say 6 sigma, it tells you how much tolerance has to be allocated to that circle. This is the standard deviation of the radius of the circle. This is the average value. This is minimum, maximum, median. And if you allocated plus minus 0.391 tolerance, you will have 6 sigma quality. That means 0 defects over a million manufacturing run. And then you can also control the precision that you want. So if you're designing high precision machinery, say nano machines or something like that, you can get very accurate idea. And then you can save the results in the CSV format, and I'll show you how you use that a little later. So you can allocate any dimension. For example, this is a diameter here. I can analyze and find out how much tolerance to give to the diameter. So this is the allocation part. And then we will show you how you can deallocate tolerances also by doing reverse tolerance analysis. So let's look at a couple of examples that will make the concept a little clearer. Here is a situation where the user has designed the glass using optics software, and then the mechanical part has been put together using a CAD application. He wants to do a conceptual allocation. So this is not really going to be 0 degrees. It's not going to be a really horizontal plate. This will have a tolerance, and the user wants to know what would be the tolerance of the output beam. How much tolerance should he be able to allocate to the output beam so that this will perform to a certain quality. So the user clicks on the line, and this is the freedom I want to allocate the tolerance. So I click the right mouse button, and let's say -0.1 and +0.1 degree. Immediately you can see the angle is being affected. Go to tolerance analysis. I'm designing for 3 sigma. This is the amount of tolerance I need to allocate. That was a pretty quick answer. Let me just, so that you know how long it takes, let me put 1000 here and see how long it will take you to get the answer. So it's pretty fast. I mean, 10,000 iterations is, a few seconds. So this was a kind of a static assembly, and the user could allocate the tolerance. But let me close this and come to a mechanism which the user wants to know the tolerances in the various positions of the mechanism. So this mechanism actuates based on the value in this cell. So if I say 290 degrees, the mechanism is actuating. So before you do tolerance analysis on a mechanism, you have to make sure that you have constrained the mechanism correctly so that it's going to follow the functional behavior of the actual assembly. The user wants to know what is the effect of tolerances, for example, at the x coordinate of the end of this line. So just clicks on the line and calculates the x coordinate. And now he's allocating tolerances. So let's say there's a polar tolerance on this pin of whatever the polar tolerance is, let's say 0.1 millimeter. Immediately it starts affecting the point of interest. Let me increase its precision a little bit. Let's say this link is not going to be really 65 millimeters, but I'm going to click the right mouse button and give a tolerance to the length there. I think you're getting an idea. So, and then this calculation is clicks on the cell and say analyze tolerances, and I'm going to design for 3 sigma. So it tells me that the tolerances of that point is 0.041 plus minus. If you allocate that thing, the assembly will work to 3 sigma. But let me just save this experiment as a CSV file. Let's say we call it case 1, because I then take the mechanism to, let's say, 280 degrees, and I do the analysis again, same analysis, but it says you need to give a little bit more tolerance in this position. So let me just save it as case 2. So like this, I'm saving the results in a CSV format, and then what I can do is I can start Excel, and let me open